video, we're going to look at the binomial distribution. So we're going to start off just by looking at an example. Suppose I want to know the probability of getting 3 6s and 5 throws of a die. Well, there's a whole lot of different ways in which that can happen. I could get 2 non-6s followed by 3 6s. I could get a non-6 followed by a 6, followed by a non-6, followed by my two more 6s. I could get the first 3 throws with 6s and then 2 non-6s. So in fact, each of these different combinations, and that's exactly what they are, happens in exactly the same number. The likelihood's exactly the same for each. It's because I need to get a non-6, which has got a probability of 5 6, another non-6, 5 6, and then 3 6s, each of which has a probability of a 6. So if you look at each of these fractions, each of these terms rather, they each have the same makeup. Two factors of 5 6 and 3 of 1 6. The 10 different ways, 10 different combinations in terms of the different ways I can get the 3 6s and the 2 non-6s. And this number over here, okay, so the overall probability works out to just over 3%. But this number over here that we're talking about, this number, is actually the number of ways in which I can choose 3 throws from the 5 on which to get 6s, or indeed 2 throws from the 5 on which to get non-6s. So let's look at another example. Each day I go fishing, I have a 70% chance of success. What's the chance that I'm successful on exactly 2 days on a 6-day trip? Well, I need the 0.7 to happen twice. If I'm successful on exactly 2 days of the 6-day trip, I need the lack of success, the unsuccessful days, to happen 4 times. Notice that these two add up to 1. It's a binomial distribution. There are only 2 outcomes. And then there are a number of different sort of combinations in terms of which days I could catch the fish on or not catch the fish on. So over here, I'm going to put either 6 combination 2 or 6 combination 4. And let's just have a look at what that comes out to. Right, so I'm going to go 6 combination 2, which is 15. Then I'm going to multiply that by 0.7 squared. Then I'm going to multiply that by 0.3 to the power of 4. And I get a final answer of just about 6%. So this formula over here is the one that gets given to us in the exam, the matric exam. And basically what it says is the probability that big X is equal to little x is the number of ways I can take x objects from n objects with x happening, with x sort of successes and n minus x failures. So there's a way of writing down these binomial distributions, but before I show you how to do that, just to stress that binomial distributions happen when we only have 2 possible outcomes. So we've got success and non-success. So those 2 always have to add up to 1. And the probability of each outcome is fixed. So for example, if I toss a die, each time I toss it, I get exactly the same chance of getting a 6 or 5 or whatever it might be. The way I write down one of these probability distributions is exactly the same format as the formula is given in. Right, so I'm throwing a die 3 times, and I want to write down the probability distribution for the number of 6s. So the probability of getting a 6 is 1/6. And if I want to get x of those, right, so that's this piece over here, then I need to get non-6s. Probability of getting a non-6 is 5 6. I'm throwing the dice 3 times. I need to get 3 minus x non-6s, right? And then I add those 2 numbers together and I get 3. and x. And this is the number of combinations on which the x6s can occur. I could also put 3 minus x here. The different values that x can take on, x could equal 0. Obviously, I could get no 6s. I could get 1. I could get 2. And I could get 3. Every other value of x has a probability of 0. So we just write 0 elsewhere. And now what I've done down here is I've worked out that probability distribution. So the probability of getting 0 6s, just about 58%. Probability of getting 1 6, probability of getting 2 6s. The probability of getting 3 6s, half a percent. You add all those up, and not surprisingly, you get 100%. Just for what I've done here is I've got a graph of that probability distribution. So this is called a probability distribution. It's the way that the probabilities are distributed or shared for a kind of an event or a series of events. Just while we're here, just because we can, the probability of getting at least 1 6 and 3 throws of a dice, well, that would qualify, that would qualify, that would qualify. Remember, the only one that we don't want to count is this one. 1 minus the probability of none, which is 1 minus about 58%, so about 42%.